Yes. All right, so look at number 1. What do you have to always look for first? Anybody? GCF. Thank you, Casey. So when you take out that GCF, if you were to do grouping, they don't have the same kind of stuff in common, right? It's not going to work out like this one. So you just leave it like this. That's the only thing there. Don't let it scare you just because of all that craziness. All she did was take out an X. All right, what about number 2? Most of you, when I walked around, it looks like you got to about this point. All right, so you did grouping. And these two had an n squared in common, which is what she pulled out. Are y'all okay? Did y'all get to this point? But this one right here, n squared minus 9, that's the difference of 2 squares. So you could break that up. You pull down the n plus 2, and you can break that up as n plus 3 and n minus 3. Are y'all okay? Yes, no, maybe? All right, what about number 3? So the factors of 6 were 1 and 6 and 2 and 3, right? Both of those will give you negative 5. Why did we pick negative 2 and negative 3? What? Yes, thank you. The negative times the negative would be the positive 6. Very, very good. This right here, when you have this 5 and this 6, there's about 3 different ways that I could write this, and all of them have 3 different answers. So be really careful and make sure you check which one gives you the positive 6. Are y'all okay with that? All right, let's look at number 5. We're going to skip 4 for right now. Let's look at 5. Do you see this theta that they give you right here? They're giving you this angle. Okay, they want you to remember SOHCAHTOA. And what is 7 to that angle? It's not the adjacent. No, it is not. That's the opposite, right? So it's not cosine because the O stands for opposite. So 7's on top. And what is the 5? That's the adjacent. So the opposite and the adjacent is tangent. Are y'all okay? All right, what about number 4? What does product mean to do? Multiply them, right? So I'm going to multiply those two. Most of you skipped it, and you could have at least done that. What's that look like? Foil. Foil. All right, what's my first? Uh-huh. What's my outer? Uh-huh. What's my inner? Plus 12L. Yep. Oh, I think you wrote yours backwards, Sam. Oh. Sorry. I just read it in the order they gave it to me. But it's still the same thing. And then 4 times 4, 16. What happens to the middle two? They cancel out. So I've got negative 9i squared plus 16. Huh. That's not an answer. There's a reason for that. Do you remember when we had in piecewise stuff, you would get like negative square root of 3 or square root of negative 3? And I would tell you, don't tell me that's no solution because there's coming a time when you will learn how to break that down. Remember that? Yeah. Okay. So also, do you notice how I always change these letters up, but I never give you an I? There's a reason why I never give you an I. Because I is what we're going to learn in the coming months, and I squared is negative 1. And you're going, Miss Blackman, why are you teaching me something new and that we haven't even gotten to yet? Oh, because it's on the ACT. And because there's an ACT Saturday. You're welcome. Okay, so anytime you see I squared is negative 1. Okay, if you're not taking the ACT this Saturday, hopefully you're taking it before much longer. There's a next one in December the 10th, okay? So I squared is negative 1. So here I can say negative 9 times negative 1 plus 16. So that's positive 9 plus 16. And how much is that? 25. There you go. Looky there. That's C. Are y'all okay? You've got to build up your endurance, guys. Y'all see these crazy problems and y'all just give up, okay? You can't just give up. You got to push through it. All right, here's what we're going to do. I am going to pass out your notes today. So, like, the struggle was real this morning because I made copies of all. I guess I just love matrices so much that I made all of your copies for matrices again. So I had to throw away a couple hundred copies. And so the struggle was real this morning. So you've only got one page of your notes instead of all of them, but I'll give you all the rest of them on Monday, okay? Does that make sense? Huh? Yes, I recycled them. Why did everybody ask me that question today?
Because that's a lot of paper.
I know it's a lot of paper. Trust me. I stood there and waited on all that paper to copy, and I was upset.
I'm sorry, I thought I was doing my paper sheet.
I guess I just like matrices that much. We just won't do it again. Yeah. They're not that behind.
Stop. No, we just walked on there and they were teacher. He said they were on matrices that they were still on whatever you did before this. That's right. They're on that. I forgot whose t-shirts, but never mind. Maybe it's not there. I don't know why. Yeah, I don't know if I find it.
Did he go to this school, y'all? Huh. Okay. All right. Here we go. Shoot. So, you got your graphing calculator because you need it if you haven't gotten one. I warned you earlier today. Let's look at this, shall we? Oh, we got some vocab. All right, in a blank function, the greatest exponent is 2. What kind of function is that? Quadratic. There you go.
How are we going from matrices to this?
Trust me, they go together. You'll understand. Patience, grasshopper. All right, these functions can have a quadratic term, a linear term, and a constant term. That you see that word, they can. Not that they have to, they can, okay? So they're going to have a quadratic term, they could have a linear term, or they could have a constant term. The only thing they have to have is a quadratic term. The rest of it they could have if they wanted to, but they don't have to have it. What's wrong, Sam?
Oh, I just don't pop.
Oh, okay. I do too. Somebody must be cooking it for lunch. All right, so the general quadratic function is shown below, okay? Do you see how it has x squared? All right, are y'all okay? Why is this a linear term right here? Because it's not squared, right? Remember all those functions where it couldn't be linear if it had an exponent other than 1? And you couldn't multiply letters together? Couldn't have a letter in the bottom? Do you remember all that stuff? Okay. All right, why is this a constant term? Because well, in reality, the C stands for a number, right? It's just a number. Okay, so the graph of a quadratic function is called a parabola. Dun, dun, dun. There it is right here. It's a parabola. Don't you do it. I will send you out of this room. You're an algebra 2 trig. Don't do it. Mm-mm. So to graph a quadratic function, you graph ordered pairs that satisfy the function. And that's what we're about to learn, okay? So if you got a highlighter or a different color, you may want to highlight some of this stuff. All right, so here we go. Consider the graph of y equals ax squared plus bx plus c, where a cannot equal 0. Okay, what in the world does that mean? A cannot be 0. Why can a not be 0? Because then you wouldn't have a what? You wouldn't have a quadratic, you would just have a linear. So it would be a straight line instead of a u, right? Alright, so the y-intercept, what are we going to plug in for y-intercept? No. What are we going to plug in? 0. Why are we plugging 0 for y-intercept again? Why? But why are we plugging 0? Why did I plug in 1 or 10 or 7? Because it hits the y-axis, right? And where it hits the y-axis is like an intersection. And when you're driving at a red light, what should you do when you come to an intersection at a red light? Stop, because you should come to 0, right? Okay, so that's why we're plugging in 0 for the y-intercept. All right, the equation of the axis of symmetry, this is what you need to know right here, is x equals negative b over 2a. So when you find that, that's x equals, right? So when you find that axis of symmetry, that's your x-coordinate for your vertex. So that's going to make some sense in just a minute, all right? So where is the axis of symmetry in this picture? In the middle? And what does it do when it's in the middle? It what? Y'all gotta speak up. I heard the line that it all based on something. Be more specific. What does that line do? It splits it in half. So that means that both of these sides are symmetrical. That's the vocab word I was looking for. They are the same, but the symmetrical was the vocab word I was looking for. There you go. Symmetrical does mean the same, though. So you see how both of these sides are the same? All right, so here we go. Everything stems from your vertex. Your vertex is this point right here in this curve. Does that make sense to everybody? All right, here we go. Let's look at number 1. All right, number 1, we got a lot of stuff to answer, okay? So what is the first thing it tells us to do? Find the y-intercept. Okay, so how do we find the y-intercept? What number are we plugging in? 0. There you go. So f of 0 equals 0 squared minus 6 times 0 plus 8. So that is 0 minus 0 plus 8. That is just 8. So the y-intercept is at 8. Now, if you're very intuitive, you could realize that your y-intercept is always just going to be what? The constant, which was 8, right? Does that make sense to everybody? Because if you plug in 0 for both of these, they're going to go away, and all you're going to have left is 8. Anybody lost? Where? Are you just saying that?
Yeah, yeah, I am.
Are you sure?
I am, but I'm getting to figure it out.
Okay, so it's right here. It said find the y-intercept, right?
Sure.
And intercept means that we're going to go up and hit the y-axis. What is the x-coordinate on the y-axis? The x-coordinate is 0. That's why I plugged in 0 to those x's.
Oh, okay.
And when I do that, I get 0 minus 0 plus 8, which is just 8.
Yeah.
So this graph is going to go up 8 and hit the y-axis.
Got it.
All right. What else does it tell us to do? Oh, no, it doesn't yet. You better keep reading A. Equation of the axis of symmetry and then the vertex, right? So we can abbreviate.
Miss Blackman?
Yes, ma'am.
Is Daniel the Friday in there?
Yes, ma'am.
Was he tardy this morning?
Were you? He says no.
Okay, thank you.
That was easy. All right, so the axis of symmetry, we abbreviate that as AOS, axis of symmetry. Or you can write the whole word if you want to, but I really don't want to. I know. I got other stuff to do. What time do we get out of here? 22. Okay. All right, so what do we do with the axis of symmetry? There was a formula. Negative b over 2a. What in the world does that mean? Okay, so you got negative, so x equals negative. B is the B is the second number that they give you, which is negative 6 over 2 times A is 2 times the very first number they give you. How much? What number's there, people? 1. Thank you. All right, these two negatives make a positive, and 6 over 2 is 3. Y'all okay?
Where does the 1 come from?
The very first number they give you is A. So, Sam, right here, this is A, this is B, B, and this is C. A is understood to be 1.
Oh, okay.
That's why I plugged in -6 right here, because it's negative B over 2A. All right, so my vertex is the last thing it tells me to find. Vertex is important because everything stems off of your vertex. But you've already found half of your vertex right here. X equals 3. X equals 3. So 3 is your X coordinate. Y'all okay? So how would I find this Y coordinate? You plug it in. There you go. So f of 3 is 3 squared minus 6 times 3 plus 8. So that'll be 9 minus 18 plus 8. We'll see that's 17 minus 18. That's -1. Y'all okay? Now what's it tell us to do? Now we make a table of values, but dun dun dun. Your calculator will do it for you, people. Alright, so turn your calculator on. Bless you. I would not lollygag if I were you, because we're learning something new for some of you. If you had me for Algebra 1, you're not learning anything new. Yes, ma'am. But the formula is negative B, so negative -6 makes a positive 6. So the negative just changes the sign for that B. All right, here we go. Where do I go to graph something? Y equals right here. And if there's anything in Y equals, then you hit the clear button. Stay with me. All right, where is my X? My X is, find the green button. It is directly to the right of the green button. And then we're going to square it, which is right below that inverse button that we just learned not too long ago. And then subtract 6x. And then plus 8. And then you can graph. You do not have to hit enter. You can if you want to. Hit graph and you should get a nice pretty parabola. And looky there. Oh my goodness, if I go up 8, what happened when I went up 8? There's the y-intercept. There you go. All right, now, my calculator will give me a table of values. So come on, my freshman babies that I had. Where we go? Second graph or second table, however you want to say it. Y'all okay? All right, then you find your vertex because everything stems from your vertex. So your vertex was 3, -1. So scroll up or down. In my case, I have to scroll down until I find the vertex. Second graph or second table. Huh? Do what? Batteries are dying. You typed something in wrong. Bring it to me. Because right above graph is a blue and it says table. Lord have mercy. You got to clear all this stuff out. Somebody's been messing with it. And you didn't hit an X for 6. Right here. You have X squared. But then minus 6X plus 8. Now you should get that. Oh, your dimensions. Hold on. Oh, minus. Golly. Now it should do right. There we go. Got it? Okay, so grab you a piece of graph paper because what does it say in part C? Use this information to graph the function. Yes, ma'am. Okay, here we go. Ooh, my screen almost went black. So you got your graph? Yes, dear?
My calculator just gives me fractions and I don't know how to change them.
Okay, hold on. We did this in 9th grade. I'll refresh your memory. So I'm just going to do it from up here. So everybody disregard this but Abby. Abby, remember, go to table set. Remember that? Second table set. And table start tells it where to start. But if you go down one, change in table tells you what to count by. To count by ones. Then go back second graph. Is it fixed? Still?
Oh, because you're telling me. I'll start at 1. Now I'm second table. There you go.
It wasn't decimals, it was in scientific notation because you had such a large number in there. All right, so we're going to graph our vertex first. So our vertex is 3, -1. So we're going to graph that first. All right, now everything stems from my vertex. So what numbers are around my vertex that I can graph next? 2, 0. And what else? 4, 0. There you go. Doesn't really matter. You're going to graph them all anyway. All right, what else can I graph? Let's see. I did 2, 0, so I could do 1, 3. And what else did I have? After 4, 0, I had 5, 3. Ooh, are you noticing a pattern? The y's are the same. Why is that? Because your axis of symmetry means that both sides are the same, right? So that means your y values are both going to be the same. All right, so that means when I have 6, 8, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Oh, dang, I didn't leave myself in another room. I can't do that one. So do you see that nice, pretty U shape that happened? Yes?
Yes.
Okay. And it should be a nice, pretty parabola. Do not make it a V, because what kind of graph is a V? absolute values, and I am a stickler on it. Do not make it look like a V.
Where did the two higher points come
On my table. 5, 3 came after 4, 0. And 1, 3 came before 2, 0. I'm just looking at the numbers on my table. I did. It's right here.
from? You just chose the two that's under.
You always start from your vertex, and you just choose the ones that are right next to your vertex. I would have used 6, 8 if my graph would have been big enough, but I don't have enough room on my graph. All right, let's look back. What else did it tell us to do? Bless you. Determine whether each function has a maximum or a minimum, right? Everything stems off of your vertex. Look at your vertex right here. Is that at the top of your graph for a maximum, or is it at the bottom of your graph for a minimum? It's the bottom, so it's a minimum value. Everything stems off of your vertex. All right, but then it said, use this, determine whether each function is a minimum or maximum value, and then find that value. So that value is 3, -1. It's your vertex. It's your vertex. You don't really have to find it. I just want you to understand that it's your vertex, okay? What else did it tell us to do? Ooh, I told you it wasn't going away. But here's the deal. You ready? Domain is always the same for a parabola. No matter how you flip it, if it's a parabola, your domain is always the same. Okay, so what were my domains? My x's or my y's? Your x's, right? So from your vertex, what are your x's doing? What is this graph doing? It's going out and it's also going up, right? So my x's are what I'm concerned with. So if it's going out, slowly but surely, it's going out to what because of those arrows? Negative and positive infinity, right? Which I can simply write that as what? All real numbers. There you go. Or you can write negative and positive infinity if you want. I'm just going to write all real numbers. My range, however, will be different. All right, what's the song? Started from the bottom, right? What's your bottom y value? -1. -1 does not get a bracket because it's a number. It gets a bracket because what kind of dot is right there? Closed. And then where does this go to? Infinity. There you go. It is light work. It's a lot of questions, but it's light work. All right, let's look at number 2. So we got to flip over. All right, keep the front of that handy because we got to know what questions we got to do. All right, what's the very first thing it told us to do? Find the y-intercept, right? So how do I do that? Oh, I just plug in 0. Or, oh, I could just know what? It's 6. But for those people that need it, let's plug in 0. If you know it's just 6, then just write 6, people. Y-intercept is 6.
Will it always be given?
It's always your constant. All right, what else did it tell us to do? No. Axis of symmetry. Axis of symmetry. So the axis of symmetry formula was x equals -b over 2a. So negative is in my formula, so that negative is always going to be there. Then what's your b? Your b is your second number. -10. So it's -10. And then 2 times a is 2 times your first number. What's your first number? -5. There you go. So -10 is +10. 2 times -5 is -10. So your x value, your axis of symmetry, is a vertical line at x equals -1. Then it told you to find your vertex. But that's easy because I've already found half of it. My x value is -1. Y'all okay? Alright, so then how can I find my y value? Plug it in, plug it in. There you go. Huh? Y'all seen that commercial? Glade commercial? Please tell me y'all are not too young for that. Okay, look, here you go. Plug it in your calculator. Take your calculator. How do I get out of what I was in? Second quit. That's how you get out of everything, right? You don't always want to hit clear because sometimes you'll clear your data. Alright, so you're going to do -5, parentheses, -1, close your parentheses. Once you close your parentheses, then you can square it. If you don't, you tell your calculator something different, okay? So subtract 10, parentheses, -1, and then close parentheses plus 6. And it'll give you your answer. Y'all okay? Alright, what are we supposed to do from there? Make a table of values. So I got to go to y equals and clear it out. Don't be lazy. Clear it out. Alright, so we got -5. And then x is right next to the green button, squared. And then subtract 10x plus 6. Do you see the difference in size between the subtract sign with the 10 and the negative sign with the 5? You see the difference in size between the two of them? Okay, all right. You don't have to hit graph because we don't really need the graph right now. We need a table. So we hit second table or second graph, whatever you want to call it. What am I looking for first? The vertex, which is -1 and 11. So I'm going to find that first. Now this is quite a large graph, so you need to make your graph pretty large. Huh? Yes, dear. I'm looking for it on your. I'm looking for those specific points on your graph. Alright, this graph is pretty large, guys. Alright, you ready? What do I graph first? Your vertex, which is at -1 and 11. All the way up there. Alright, so Chris, I'm going to find my points that are right around my vertex, okay? So the first one around my vertex is -2, 6. The other one is 0, 6.
Miss Blackman,
Yes, ma'am.
is Daniel the Sabe with you?
Yes, ma'am.
Daniel, did you check in this morning? No? Okay, thank you.
Huh? Should
Did you come in late?
Huh? He said he was at her door when the bell rang.
Okay, very good, thank you.
Alright, where are we at? So then we had -2, 6. 1, 2. Look at that, there's my y value, right? What, my y value 6? Okay. Let's see. Then I have 1, -9. Whew, Lord have mercy, this is a big graph. And I know I gotta have another 9, right? I gotta have another one over here somewhere. So that's -3. Alright, so look, you've got to draw this so it looks like a parabola, okay? So let me show you the trick that I do. because you don't want, this is really easy to make this look like a V, okay? So what I do, this is just me, is I go up to the top and I go ahead and curve that so it makes it look like a U, and then I just connect my dots from there. You don't have to do that. I'm just giving you some advice, because if you make it look like a V, I'm taking off points. I just go up here to the top, and I just go ahead and round that at the top, and then I just connect the dots. That way it doesn't look like a V, it looks like a U. Just a really skinny U. Alright, so is that a maximum value because my point is at the top, or is that a minimum value because my vertex is at the bottom? That's a maximum value. And then it wants you to find that value. That value is just your vertex. So what was your vertex? Negative 111. Alright, then what's it tell you to do? Domain and range? Domain is always, no matter how you cut it, for a parabola, it's always what? All real numbers, which is negative infinity, positive infinity. There you go. It doesn't matter which one you write. Why is that? Because from your vertex, what does it do? As it goes down, it is also very, very slowly getting wider. Are y'all okay? Alright, what about your range? Ooh. Very good. Starting from the bottom is negative infinity. Start from the bottom, now we're here, right? What is that, 11? And it gets a bracket. It does not get a bracket because it's a number, people. It gets a bracket because it has a closed dot. Y'all okay? Anybody lost? Okay, so let me show you a trick real quick. You ready? Look back at number 1. These were all x squared graphs, right? So I'm going to show you how to graph these without using a calculator really quick. So number 1 was x squared minus 6x plus 8. Was that right? Yes. Okay. When this front number is 1, and only when this front number is 1, start at your vertex. What's 1 squared?
1.
So I went out 1 and up 1, right? Okay, what's 2 squared? 4. So I went out 2 and up 4. What's 3 squared?
9.
So I could go out 3 and up 9, but I don't have enough room. Does that make sense to everybody? It's a really quick and easy way to graph it. So if you're on an ACT and your batteries die or something happens and you don't have this, then if this number is 1, you just go out 1, up 1, out 2, up 4, out 3, up 9, out 4, up, out 5, up, out 6, up. There you go. Does that make sense? And since it's symmetrical, it's the same thing on the other side. Are y'all okay? Now, this one's a little different because this one was negative 5x squared. What was the rest of it? Minus 10x plus 6. Okay, this one's different. I can't go out 1 and down 1. I went out 1 and down 1, 2, 3, 4, 5, right? Why did I go down 5? Because 1 times 5 is 5. Does that make sense to everybody? Y'all okay? Y'all look like zombies. Alright, I'm not going to go out 2 and down 4. I'm going to go out 2 and down 4 times 5. What's down 4 times 5? 20, which is why I went out 2 and down 11 plus 9 more was 20. Are y'all okay? Anybody lost? That's what we had to do it back in the old days before we had calculators. Okay, number 3. Last one. Here we go. Number 3, number 3, number 3. I want to try to get to some really cool stuff on your calculator. Some really cool stuff. If you came to the ACT seminar, I kind of taught you how to do it a little bit yesterday. All right, here we go. Let's do this quick. What is the y-intercept? 5. If you don't know how to get that, you do 2 times 0 squared minus 8 times 0 plus 5. And that is 0 minus 0 plus 5, which is 5. There you go. What about your vertex? I'm sorry. Axis symmetry comes next. Alright, axis of symmetry is negative b over 2a. So, negative what? Negative negative 8 over 2 times what? 2. So that's positive 8 over 4, which is 2. That means that at x equals 2, you have a vertical line, which is your axis of symmetry. Y'all okay? Alright, now we can do our vertex. Because we already have the first part of our vertex, which is 2. Because it was x equals 2. So now let's plug it in. F of 2 would be 2 times 2 squared minus 8 times 2 plus 5. And you just plug all that straight in your happy little calculator here. Did y'all know your calculator was happy? Are y'all happy? Oh, that didn't sound very promising.
I will be tonight.
Why, at the game? Why are you not happy right now when you're better in your life? Uh-huh. Y'all okay? Anybody lost? Alright, go to your y equals. And clear it out. Don't be lazy. Alright, we got 2x squared minus 8x plus 5. The more times you type it in, the faster you're going to be able to get to do it, okay? When you're on the ACT, time is money. Alright, so hit graph. Well, you don't really even have to hit graph. I shouldn't have done that, sorry. My slow calculator. Alright, hit second table, second graph, whatever you want to call it. I'm going to find my vertex first. My vertex is at 2 and 3. This is not a bad size graph. This is pretty small. Alright, so let's see. Bless you. What's wrong? You sure? You okay, Caitlin?
She said she went straight.
Do you need me? Okay. Alright, first thing you grab is your vertex. What's my vertex? 2, -3. Oh, that's -2. 2, -3. Alright, what numbers are around 2, -3? 1, -1. And 3, -1. Looky there. Instead of going out 1, up 1, I went out 1, up 1 times 2. What's 1 times 2? 2. Alright, what's the other numbers around those? 1, 2, 3, 4, 5. Oh my gosh, that's my y-intercept, right? Didn't I get my y-intercept was 5 earlier? Wow, you see how I'm checking my work? And I should have another 5 somewhere over here. 1, 2, 3, 4. How am I smarter than y'all? I'm older than y'all. That's about it. Which means, no, that means I've had more experience. You will get there one day. Patience, grasshopper. Alright. Don't worry. Many of you will go on to do bigger and better things than I have. Build houses. Hey, you know what, buddy? You can come build my house any day of the week. That's alright. As long as you know your math. If you don't know your math, you can't come build my house. Okay. Are y'all okay? Alright. Alright, everything stems off the vertex, right? So is this a minimum value or a maximum value? Minimum. Alright, so that, I need that point. What is that point? Oh, that point's my vertex. I've already found it. What is it? 2, -3, right? Yep. Alright. What do we do next? Domain? Oh my gosh, domain is so hard. Oh no, it's not. What is it? All real numbers. Or negative infinity, positive infinity. Doesn't matter. What? Something we need to share? Ethan? Casey? You got something you want to share? Oh, okay. Alright, what about your range? Start from the bottom, now we're here. -3. Why does it get a bracket? It does not get a bracket. Because it's a closed dot. There you go. It does not get a bracket just because it's a number, okay? Then where does it go to? Positive infinity, and infinities always get a parentheses. You good? We're not done yet. Okay, here we go. So we are going to determine whether each function has a minimum or maximum value and find that value. Then we're going to state the domain and range of that function, okay? No. Now, what does this negative do to this graph? It flips it upside down, people. So what would that have? That would have a maximum value. I know. You don't need to use your calculator for everything. You need to use your brain for some things. So, since we have a maximum value, it wanted us to find that maximum value. How do we find that maximum value? What is that maximum value? It's your vertex. So I got to find my vertex. So that'll be x equals negative. Oh, Lord, I don't have a b. Or do I have a b? Why is it 0? Why isn't it 12?
It's not there.
Because you don't have an x right here, right? Your a is the -1. The 12 does not have a letter, which means your 12 is your c. That's your constant. So you have -0. Huh? What's -0? That's just 0, right? And then 2 over -1 would be just 0. So my value would be 0 for my x. And I got to plug that in to find y. So ladies and gentlemen, if I plugged in 0 right here, what would be my y? -12. Oh my gosh, that was so difficult. I know. And what's my domain for every parabola? All real numbers, or negative infinity, positive infinity. And what's my range, people? Starting from where? No, starting from where? The bottom. Look at the picture, people. It's upside down. So it's negative infinity. Then it goes to -12. Y'all okay? That was so difficult, wasn't it? All right, what about number 5? What kind of shape is that? What kind of shape is that? Oh, what kind of a U? A regular U with a minimum value. There you go. Because it's positive in the very front.
Regular just means
It's a regular 4, which means it's a regular parabola. This is a negative, which means it flips it upside down. Just like 3 was a regular parabola, but 2 was upside down because it was negative.
I thought you just came out with
No, I mean, it's a regular U. This is like an N looking thing. All right, so what's that value? I have to find my vertex. So let's see. Negative x would be -24 over 2 times a would be 2 times 4. So that'd be positive 24 over 8, which is 3. That's your x value. And then how do I find my y value? I'll plug it into my handy dandy calculator, my happy little calculator over here. I don't even have to write it down if I don't want to. Be 4 times 3 squared minus 24 times 3 plus 11. What you get? Alright, same thing I got. Oh my gosh. I'm just dying over here from how difficult these are. Alright, what's my domain? All real numbers. I feel like I'm insulting your intelligence because this is so easy. Alright, what's the bottom? -25. What's the top? Infinity. You should be offended at how easy these are. You should be. It's all good? Oh, now this is the one thing y'all don't want to be offended at? Okay. We will start with exploring our calculator. We didn't get to it. This is the good stuff. Don't be absent on Monday, people. Don't be absent on Monday. When I say good stuff, that means like if you're absent, you're going to be really far behind, okay? So don't be absent.